Hi everyone, this is Lab 2, Stemming and Part of Speech Tagging with NLTK. I'm Ricardo Lu. I'm a teaching assistant at Test Analytics class. From previous lab, we talked about tokenization and stop words removal. We aggregate all the words that have the same characters, and we removed all the stop words. It looked very clean. But for now, we have other problems. We know that the words are clean, but we are not sure that if words have same meaning, we aggregate together properly. Also, we are not sure that they are nouns and verbs, which make a big difference because verb, when it stands for itself, it doesn't mean a lot of things. So let's get started. We'll talk about stemming and POS for now. Let's import data. This time we have import new over here. This one is a shorter version of the text from last time. And same thing, we read it, but this time we read it binary. We can use the other method we mentioned in lab 1. So as we can see here, we import it and we tokenize it. Use the NLTK library. We use a function called word tokenize. Then let's see what are tokens. The tokens over here, as we can see, we take it word by word. And also we have all the punctuation marks over here. And we can see the list is still the same sequence as what the test file is, right? And then we have words. The words are all alphabet and all lowercase. So it basically removes everything that's with the digits, and also all lowercase everything. We'll mention the difference later because we use tokens and words in different ways in later steps. First stemming method is called proto-stemmer. The difference between different stemmers is how aggressive they are to process the words. The difference when we use different method, it just over here, we call different methods when we want to use it. So we use the proto-stemmer over here, and we proto-stemmer to stem the words. So we stem each word over here, and then we do a frequency plot. And that's the result of what is stemmed. We can see camera, we can see video, we can see use, which is pretty normal. Over here, this is the frequency plot. The second stemmer that we can see over here. So we kind of expect something camera, but there's no A in it. And we also expect like this, the prototype of cameras are also congregate together. But we can see there's a different frequency level over here from here. Basically, the algorithm behind the function is different. And the third way to stemming the words are WordNet limitizer. So as we can see over here, it has similar camera. It has similar US. It should be USE, right? Because as we see the frequency plot over here, it should be USE, but it definitely, because of stem method, when we interpret it, we definitely need to go back to what it really come from, right? Just like we can see it over here. So the plot looks really similar because the camera is still the most frequent ones. And then what we can do is we save one of them into our file. I think this one is saved, let me see, it's saved soft frequency 1, so the Porter stemmer, right? It saved the Porter stemmer over here to your directory. Second, let's look at part of speech tags. Part of speech tags, basically as we learned in the class, we tag each words to know they are nouns, they are plurals, they are singulars, or they are proper ones. So as we can see, it's tagged as NN, NP, NS, and PS. So maybe you are not familiar with proper noun, but proper noun means that you're talking about specific words, like specific name, like word bank. So again, we don't need to remember this particular library get downloaded. Sometimes it will ask you to download specific library when you run code. But don't worry, just put it in the front. Next time you run it, there will be no problem at all. So, and it will return true. We already downloaded. And as we can see over here, we need to proceed unpreceded tokens, not words over here, because POS really care about there's punctuation marks inside. There's some words are capitalized, and you cannot remove the ones that with digit because it means something. It will help them to process, to understand if it's a noun or a verb or others. So the thing to remember is that we use unpreceded tokens, processed tokens, but not words. And then we make a list. We can see that the post tag, after we adopt a function of tokens, there's sub list inside. You can see that it has something over here. And we know that's a noun. It's not a proper noun. It's a sensor, but not something particular. And we know word by word, each one is to give a tag. It's not very, very accurate, but it's not perfect, but it's kind of accurate in some way, as we can see in the result. Let's see. And we get a sorted frequency over here. And we can see the tag list, the sorted frequency. After we sorted, we can see kind of very similar result from last time. We have 540 of camera, but the others, as we can see, we already removed all these in the other analysis. But we can see that T3I is over here, which is good because we know it's a noun. Noun is very important over here because we know for sure what it means. Over here, it might be it's a type of camera, and we can see it may be compared with T2I. So that's the result over here. They're all the nouns. how we did it, how we leave all the nouns over here. So we come back to our steps. We check if the tag start with N. So when it starts with N, it definitely is a noun. That's how we make sure that all of those nouns are left out to make our beautiful word frequency plot. And that's the one. For me personally, I think this is a further step from last time, although it's kind of different. We have, I believe it's more informative because it had all the nouns instead of verbs like use. We don't know who used what, right? And you can find out that just the first one still has very high word frequency, and others not exactly close to it. The second one is kind of no more than half of the frequency as camera, right? So when we see all this kind of frequency, it has kind of similar pattern. So that's kind of the knowledge you have after you have test analytics class. And all of these tools are very useful in your later research. So you can come back to the video I recorded and you can try it by yourself, definitely. So let's see. Right now we can write the result into .txt file. This file, we have only one over here, sorted tag frequency. So over here, we are done with our tutorial, but we can still see our result. We get this large test file with all the comments, I believe from Amazon. We turn it into an output, a POS output, and a stemming output. This stemming output in particular is Porter stemming. This is the only one to leave the 4-term camera over here. So I recognized it, and we can see over here, this is our POS output. It has 3, as I can say, columns. The second one is talking about what kind of noun it is. So you might use different way to make a graph, to process that data. It depends on you, right? So that's all for this tutorial. Thank you for watching. And hope you enjoy it and you learn something, and hope you get a really great group project for this semester. Bye.